Okay, so the next one is about an inclined plane. So for the load to go from point A to point B, the person has to do work against gravity, but also against friction. Okay, so if the system is just a load here, you see the weight is straight down, so that will be mg. You're gonna have the normal force perpendicular here. You have, let's say the person is pushing in this direction here. That will be the push. And you also have the kinetic friction in this direction, kinetic friction. So you see the weight has two components. One component, as usual, is mg cosine. So it's always the component equals to the normal force. Okay, so in this case, this force is parallel. And you have a component here which is always mg sine. So it's always mg cosine, mg sine, and here you have kinetic friction. So we already talked about inclined plane. So the work done by gravity on the load. So gravity is doing negative work because it's taking away the energy. So you have to do work against it. So it will be the component, okay, here along the inclined plane. So you have to fight against that component. So it will be mg sine, okay, times the distance from A to B. A to B. Okay? It's going to be minus mgh, right? Because sine alpha equals opposite, which is h over hypotenuse. So that work will be minus the mass, which is 5 times 10 times 2. So that's going to be minus 100 joule. Okay, so you have to do work against gravity. So that will be the work done by gravity on the load. So this is gravity. Okay, so the work done by friction is also negative. So it's going to be minus the kinetic friction times the displacement AB. So that's going to be minus 0.1. And then the kinetic friction is the coefficient times the normal force. And the normal force is along the vertical mg cosine. So kinetic friction will be mg cosine. So that's going to be 0.1 mg cosine. Okay, times the displacement AB. So that will be the work done by friction. And AB is that distance here. Right? So it's going to be h, so 2 divided by sine 30. So sine 30 is 0.5, so that's going to be 4 meters. So the work done by friction is going to be minus 0.1. The mass is 5, and then you have a 10, and then you have a cosine 30, and then you have a 4. Okay, so it's going to be 0.1 times 5 times 10 times cosine 30 times 4. So it's going to be about 17 joules, and it's negative. So if you're moving at a constant speed, okay, you have to balance out this work. Okay, so you have to provide enough energy to balance out this. So the work done by you on the load would just be equals to 117 joules.